Hello everyone. Today we are going to solve a problem. Find the lexicographically smallest valid sequence from Biweekly Contest 140. And I hope you have already read the problem statement, and I will break down the problem statement for you. So we are given two strings, word 1 and word 2, and we need to find a valid sequence of indices from word 1 such that the corresponding character from a string that is almost equals to word 2. So what is the definition of almost equal? As we can see here, a string x is called almost equal to y if you can change at most one character of x to make it identical to y. So basically two string are almost equal if there is a difference of only one character in both of them. We need to return an array lexicographically smallest valid sequence of indices, and if no such sequence exists, so we need to return an empty array. Let's understand this by an example. So we have taken the first example here, this one. So we are given word 1 which is equals to VBCCA and word 2 which is equals to ABC, and we need to find the lexicographically smallest sequence of indices from word 1 that gives us almost equals to word 2. So the output will be 0 1 2. Let's see how. At index 0 we have V in word 1 but we have A in word 2. So as in the problem statement we have already read that we can change at most one word. So we can change this V to A to match these two characters, and then at index 1 we have B. So index 1 in word 2 is also a B, and index 2 in word 1 is C, and index 2 in word 2 is also a C. So basically we don't need to make any change. So the output will be 0 1 2 for this test case. Let us understand this by one more example. Suppose this is word 1 A B X A B C D E and word 2 A B C D E. Let us first discuss the output of this two string. A is matching with A, so uh, I will take 0 in our answer. Then B is matching with B, so I will take 1 in our answer. But X is not matching with C, so we have an option to replace X with some other character, which we replace with C. So we will add 2 in our answer. We will match this D with this D. So I will add 6 and 7 in my answer. But there could also be one more possible answer for this. A is matching with A, B is matching with B, but I can also match this CDE with this CDE, and I can add like 5 6 7 in my answer. But among these two, this is lexicographically smaller. This is lexicographically smaller, so this will be our ultimately this will be our answer, because this is smaller, basically lexicographically smaller. As we know, we can make only one change, so we need to make change basically here only at X. That will only give the optimal answer, lexicographically optimal answer. So till the point we are having the characters equal till AB, we don't have to do anything. But when the first time we encounter a non-matching character, then we have an option to make this character similar to corresponding character in word 2. Here as we have seen, we made this X equals to C. As in problem statement, we are allowed to change at most one change only, but we can change this character on one condition. If after changing this character somehow I will be able to calculate if after this point in word 1 and this point in word 2, I am able to find the subsequence of word 2 in word 1. Like if these characters at this point If characters in both the word are equal, then it's fine. If at some point we find some non-matching character, then we will replace it. But we will replace it on one condition, that after that particular index, we we find this character from word 2 in word 1. In this example, where we have DE, so as we can see, we are finding here D and E. So we we need to find this subsequence of word 2 in word 1 to uh, to to get our answer. My problem statements boils down to iterating in both word 1 and word 2 with two pointers, and identify the first non-equal character and check after that if rest of the character of word 2 is present in word 1 or not. So now the question is, how do we check the next part of both the string, whether word 2, whether DE is present in DA, B, C, E or not. So my next part to check whether DE is present in DA, B, C, D or not. This is a simple string matching or algorithm. You can check it by two pointer, and you can also store the last index also, where this particular string matches, which we will store to obtain our answer. We will iterate from back with two pointer and store the index where the both pointers are matching. Yeah. So also you can ask why first non-matching character you are taking. Suppose in this example we could also have changed this y to c, but that would not have been the lexicographical smallest answer. So it's always optimal to change the first non-matching character and then match the rest of the next character in both the word 1 and word 2. So I hope the explanation is clear to all of you. Let's move to the code part and understand it by code. We will iterate from the back, and if suppose two characters matches, then we will store that particular index of that character in my next match array, and then I will move to find the next character of word 2. So in this way, in next match array, we have all the position of word 2 which we have find in word 1. So we have an vector of result which we will return as an answer, and it's very simple. What we have discussed in our approach, if our two string are matching, then we have to do nothing. We have to just put in our result. If the very first time this condition fails, that means we have a non-matching character, then we will check the next match of I plus 1 is less than equals to j plus 1, which means that whether this is a condition of whether we have find this D in DABCE or not. This is the condition for it, and we have pre-computed it. We have pre-computed the index of this D in basically this string. So we have done it for every index. We have pre-computed the index of E, D, C, B, A in word 1. So we can easily find out in a constant time. So again I will update my result array. If my result array is not equals to the size of my word 2, which is expected, then I will return the empty array. Otherwise I will return the result array, which is our answer. Yeah. So let's talk about the time complexity. So this algorithm is running in order of n plus m time complexity, because we are iterating over n as well as over n, word 1 as well as over word 2. So the time complexity will be order of n plus m. Yeah. And if you found this video helpful, make sure to like, subscribe for more coding videos. If you have any questions, leave a comment below. Thanks for watching, and see you guys in the next video. Thank you.